And now we have the agenda for all this morning. Here we as you have already listened, the welcome words from our team, and in your screen you will have the agenda for this session. Maybe the agenda is a little tight, but I think that we can make it. So we will have a coffee break around 11:40, and in the first part of the morning, we will have an introduction of what is HYPERNEX. Also, we are going to speak about the observatory. That is one of the deliverables of the program. We will have a session with Jaime Tamarit, that is his organization. He belongs to the Sensenelec GTC 20 that is in charge of the standardization upon Hyperloop. After that, we will speak about the technical specifications with Stefano Ricci from DCEA. And finally, Luz Smith from Celeres will present the third deliverable, that is the transferability and roadmap beyond HYPERNEX. All the questions, please, you can use the chat, and we're going to give the word to the speakers if we have to review, or if you want to comment something, or you have some questions to make. After the coffee break, a short coffee break, we will have a round table where we have speakers, Carlo Bottini, Constantino Kaumas, Torben Holban, and Leonardo Da Giovanni. That they are going to give us some keys about what.
I'm sorry, but we cannot hear you.
Oh, sorry. Now, can you hear me? Now?
Very, very low.
Very, very low.
Now it's better.
I will I will try to speak louder in this, and I'm going to change the microphone. Sorry for that. Well, we will have the round table, and I think that our panelists, they are going to give us some keys about the future of the founding of HYPERNEX and other programs. And after the round table, we would have some questions and answer through the chat. And I think that's all. Now I'm going to give the word to Goraz Marinik, that he is our project officer, and he has been followed during all this year our steps in the project. Goraz, I think that is.
Hello, good morning.
Good morning.
Good morning from my side. Can you just confirm that you see the screen?
Yes, we see your screen.
Okay, just a
I'm
moment.
going to change my micro during your speaking.
Okay, so good morning also from my side. Good morning from Shift Rail, which is now Europe's rail, of course. And I would like to provide a bit of a context to the HYPERNEX project. So from the very beginning. So Goraz Marinic is my name. I'm a program manager at Shift Rail and now Europe's Rail. And of course, I'm also very glad to be here and very proud that the project reached this important milestone and came to a conclusion with very good results. So I will start by just explaining a bit what Shift Rail first is. So it's a joint undertaking. So it's a special organization that provides funding for research and innovation activities together with the industry. So we have 28 members and altogether more than 500 participants from different countries. out of the 28 members, there is 8 founding members, 19 associated members, and open calls. So HYPERNEX, it's an open call project. I will explain a bit later how this works. So during the duration of the program, we had 920 million euros of funds to be provided for research and innovation activities. What is ShiftRail doing? It's actually, well, as I said, providing fund for research and innovation, and more specifically in the field of rail. So the idea is to provide, to support the development of different capabilities. For example, logistics on demand, automated train operation, mobility as a service, solutions for optimal energy consumption, and so on. Very important to know is that we also look at rail as a system of systems, so not just a fragmented sub-systems, but also we look at the system as a whole. And we divided the work into 5 innovation programs. So one on the rolling stock, so on the vehicles, so technologies that improve the way vehicles function. Then the next one, IP2, as we call it, it's on traffic management and control systems. IP3, it's about infrastructure, also stations. IP4 is developing IT solutions for passengers. And IP5, it's about freight solutions. We also have cross-cutting activities looking at socioeconomic factors and noise, pollution, and so on. And the last one, also a newcomer, it's IPX, as we call it, which is dealing with disruptive technologies and exploratory research, and also developing the first rail system architecture and a conceptual data model. How the program is implemented. So we started with a master plan, which it's a high-level plan with the objectives, and from there we developed a multi-annual plan, which then results in annual work plans that are specifically intended for supporting specific projects. So from the annual work plans, we develop calls, we launch calls, open calls or calls just intended for members. And in 2020, we launched an innovation program X, so IPX, open call called Innovation in Guided Transport, with a clear challenge to put together all the activities on innovation in guided transport, namely, for example, also Hyperloop. So what was the scope of the call? So first of all, to gather all the promoters, so European and also outside promoters of technologies around Hyperloop, and then to define enhanced or innovative modes in terms of concept of operations, safety cases, functional specification, and also operational conditions and testing methodologies and the environment. And finally, the scope was also to identify the potential transferability and also synergies with the railway solutions, so that basically Hyperloop could one day be integral part also of the rail system. The expected impact was to have clarity on operational concepts, and also to initiate the standardization possibilities, and to have a structured discussion with policymakers on topics such as safety and security, and also integration at the European level. And finally, also cross-fertilization of knowledge from other disciplines, so basically to bring knowledge into the rail research and innovation, and the other way around. So the resulting project from this call, so the project that was awarded, is well, HYPERNEX, which is a coordination and support action, so not really developing technologies, but gathering different initiatives, different stakeholders. with a budget of 250,000 euros and duration of 12 months, which was later extended for another 3 months, mainly to even improve more the quality of the last deliverables with the inputs from different stakeholders. And it's a project of 13 partners from 9 countries and started in December 2020. So the project is ending end of February, so end of this month. And today you will have an opportunity to see what the project results are. What is next? I'm very glad to inform you that Europe's Rail was launched also officially this Monday. So it's the legal or the successor of Shift Rail. So Europe's Rail, it's now called. So started with the council regulation that was finalized on 19th of November 2021, and on our website you can already find the master plan and the multi-annual work plan. So if you scroll through those documents, these are still the draft documents, you will also see that we have 7 flagship areas or innovation programs, as it was in Shift Rail, and there is of course also one that will deal with guided transport or Hyperloop. So with this, I invite you to, of course, visit also our website, and I hope you will enjoy the day. So thank you very much, and congratulations again to the project.
Thank you. Thank you very much, Horace. Now this is my turn. This is my turn. I'm going to present an overall view of the project. Let me share the screen. Well, thank you very much for being here. We as UPM, as a university, we're so excited to participate and lead this project. We are also so proud to collaborate with the partners of HYPERNEX, and we have learned a lot, and we are so happy to contribute with our work to this project. A consortium has been created consisting of 4 Hyperloop promoters, hard transport development accelerators, also research centers, and universities and railways organizations, SINTEP, the University of Leeds, University of Rome, the Third, Berlin, the Institute Collegnica, and the UIC. And during this 2021, we have been working.
We are not seeing your screen.
Sorry?
I cannot see your screen.
Thank you. I know what's happened.
Now it's working.
Now. Thank you. So, during this 2021, we have been working in this project. This is, as Gora said, is a CCA project, and it's as short, no? It's not as big as other H2020 projects long. The HYPERNEX project aims to shorten the development and the implementation times of the Hyperloop in Europe by gathering all the relevant data, knowledge, and information for its development. Europe is leading the way of the design and the development of new forms of mobility, and the development of Hyperloop will help Europe to maintain its leadership. It is not only an opportunity for transport, but also for the European industry as a whole, as the Hyperloop will bring new opportunities for the development of technologies and new patents. It will allow also the movement of industry from aeronautics or railway or other sections to Hyperloop. Also, new business and logistic opportunities will be offered. Here we have the structure of our one-year project. We have 2 work packages that are related to the management and dissemination activities. And we have 3 technical work packages, that is the one that you see in the center. The work package 2 is an observatory. This observatory is about who, what, how, and where are working in Hyperloop. Also, it gathers regulation and the different challenges and stakeholders in the transport. The work package 3 are technical definition, and in it we will deep in the operation, safety, and the functional specifications. And finally, the work package 4 is the transferability of the Hyperloop. We identify the potential transferability from different programs, sectors, processes, and so on to Hyperloop, and also the transferability from Hyperloop to them. The contents of these work packages will be presented by my colleagues in the next sections. Here, all the information that we have been gathering, the partners and the results you will find in this work page in the website of HYPERNEX.eu. In it, especially, you will find the deliverables of the project. Here we have published in this moment 2 final deliverables, the observatory results and the technical definitions. The draft of the transferability and roadmap beyond HYPERNEX is already in the website, and I hope that at the end of this week we can publish the final one. So we have reached the deadline of the project, and we have achieved a lot of knowledge, contents, and data about Hyperloop. We also have been established a common framework to understand the different terms and definitions of Hyperloop. We have also created a great work team to work together in the Hyperloop topics. And also we have obtained these deliverables, gathering all this data and contents. And also we have open questions. We have new topics to work on, as evacuation, security, virtual coupling, scalability. We can work in the scalability to a commercial Hyperloop infrastructure, the operation, and also maybe the big one is the interoperability of the Hyperloop. So that's all for my side. I hope that you have a picture of the structure of the project, and I'll give the word to my colleague, Ambrose. Mitropoulos from the third, as he is going to present the results of the work package 1, that is the observatory. Lambros.
Hi, 1 minute to load the presentation.
Yes.
I think you can see the slides now, right?
Yes.
Okay. Okay. So, good morning, everyone. Good morning, everyone. My name is Lavros Mitropoulos. I'm a researcher in the Center of Research and Technology in Greece. And we were leading the work package 2, which resulted in the deliverable 2.1, which is the observatory as it was introduced. So the goal of the observatory is to map the situation in Europe and see actually what is Hyperloop, who does what, and the main components, attributes, features of the Hyperloop that are going to we're going to consider as transportation and mechanical engineers in the future in order to study the system and that will help us in its implementation. So this is just a 15 minutes presentation, and we are going to give just some basics from the deliverable. The rest of these are uploaded on the site where you can find the whole text. So starting with what is the Hyperloop system, the Hyperloop is considered as the 5th transportation mode. It's a new mode of the ground transportation and is capable of transferring passengers and cargo autonomously, reaching ultra high speeds at a low pressure environment, which is one of the main features of Hyperloop. Hyperloop fuses technologies that exist, but they need to be developed and adjusted to each case. So these technologies refer to high-speed railway and aviation. The main components of Hyperloop, as we studied them and are in detail described in the deliverable, are the pod, which we mentioned. Subcomponents are the structure, interior, electrical system, interfaces that are used for each operation, levitation and propulsion system, a very significant part of Hyperloop. The infrastructure, which is composed from tube, pylons, pressure maintenance systems, stations, airlocks, high-speed switches, and power delivery. And of course, we need the communication systems on top of these components that ensure the connection between the infrastructure, the operator, and the pod. So going into studying who does what into European Union, we managed to identify the basic organization stakeholders within Europe, and we grouped them into 3 different groups. These are the research and public organizations, private companies, and public and private initiatives. And as we can see on the right-hand side, the studies, actually the produced material, start increasing after 2016 to 2020. And actually this overlaps with the release of Elon Musk, let's say, white paper, that after that year, 2014, more or less, the Hyperloop research start increasing. 2021 refers just to the first quarter. That's why you can see only 9% of the studies here. In total, we reviewed and we identified 91 documents. We found 61 unique organizations that in 13 EU countries, and we can see on the left here on the graph that Europe has a leading role actually in the Hyperloop development, with 45% of these studies being produced by European stakeholders. The majority of EU-based organizations that are related to Hyperloop, most of them are academic or research institutes, and a 13% and 7% share is attributed to industry and non-profit organizations. So going a bit deeper to see what components actually each stakeholder are engaged into, we split it into 2 different parts, the infrastructure and the pod. We see here that in terms of infrastructure, more of stakeholders are involved into the tube development and research. Regarding the pod, and there's an outstanding 36%, of course, focusing on the system propulsion, which is a main attribute feature of the Hyperloop, and just 7% of the studies we found actually are referring and are exclusively focusing on the interior of the Hyperloop system. In terms of performance, where we want to see actually the impacts that each stakeholder studies and generates from their studies and reports, we see that the three top of them are safety, energy, and cost, with the others following, and actually very few at the moment work on legislation and risk assessment of Hyperloop. So as it was expected, safety is the #1 component part of studies at the moment regarding Hyperloop. We recorded the testing and track facilities at global level to see what is the situation. We found some testing beds more, and what we understood is that there is no full-scale corridor at the moment to test the Hyperloop. However, we can see that there are plans within the next 5, 10, 15 years to see a full-scale testing bed for Hyperloop in order to test its possibilities within in a real environment. The #1 component that actually stands out, distinguishes the Hyperloop in terms related to the other transportation modes is speed. With speed reaching up to 1,200 kilometers per hour, we understand that this is something that is going to change the system, the transportation system as we know it. So the #1 outcome impact is that we are going to reduce intercity travel time, but of course with speed we have other major challenges that are related to railway. For example, to reduce the aerodynamic drag, which is again one of the subjects that is studied by researchers and academic institutes all over the world. Another challenge is to ensure the performance, reliability, and the low cost for passengers and cargo in order to have a reliable and sustainable system. And finally, maximize the passenger safety, travel experience, and comfort within, given this speed, given a very high acceleration, and given the deceleration that Hyperloop requires. So all this within a very challenging environment that is a sealed low pressure tube environment. Going into the next step into the deliverable, we want to see in terms of speed how the Hyperloop, how speed affects some of the impacts of Hyperloop and how this Hyperloop can be developed. We can see here 3 graphs with as a function of speed, the changes with speed, and we can see that Hyperloop competes in terms of course, time, the distance that covers compared to other railway systems. We can see that, of course, we know it's straightforward that it's the fastest. Going into the cost, we can see that the Hyperloop system ranges from 30 to 90 million euros per kilometer. This depends on the pressure system that it uses, and it can compete with high-speed rail and is cheaper than magnetic elevation rail systems. So it's very competitive to other systems, and in terms of emissions, it can generate 0 direct emissions when we talk about, of course, energy that is generated by renewable sources. And within areas that aviation is restricted due to its emissions, for example, Hyperloop has a big possibility to be chosen as a system. So within this first assessment, let's say, that we want to see how Hyperloop performs, we reviewed stations, how stations can be built, where can be built within urban environment. We show that with specifics with some specifications that can be adjusted in an urban environment, elevated superstructure and good intermodal transport. We can have Hyperloop within urban areas. However, we have again here, in some areas we do not have so much space, which is an issue. And there are some social and environmental concerns when we bring Hyperloop within urban areas. On the other side, Hyperloop has a very high potential connecting low distance, destinations and origins. So we saw that it's due to the impacts that we discussed in the three graphs, it has a large potential to be implemented in long distance cases. Systematically, Hyperloop outperforms aviation on routes up to 1,200 kilometers, remain competitive beyond 2,000 kilometers, which is a distance that represents in Europe almost 90% of the flights. So we can see that in terms with other modes, it's very competing, and given a good and planning that is adjusted in every case and country, we can see the Hyperloop to be part of the system. So then we passed on transportation demand and forecast. It was a very initial assessment. We had to test to explore some of the main attributes. So in terms of passenger transport, we saw the fares. We explored the fares, and in the literature there are up to $20 in the United States fares that can go from Los Angeles, let's say, to California, which is a very feasible case. The journey time, which reduces the journey the time significantly, and the frequency that we can have both very low intervals, very short headways, and of course comfort and reliability for all passengers. Again, the Hyperloop can be used not also for passengers but also for freight transport, which is it has a large potential here, especially for commodities that are more fragile. And of course, at the very beginning, before implementing Hyperloop for passengers, Hyperloop can have a place in the freight transport where it can be tested and provide actually an image, if we can say this, that of a safe transport that can be more easily than accepted. Travel distances of less than 300 kilometers would not allow for advantages of Hyperloop, and this is due to the acceleration-deceleration characteristics, as we mentioned. And one possible way is to reduce the cost, is to use existing infrastructures as airport, train stations, and ports, where we can use Hyperloop as an intermodal chain. The observatory includes a short case for Europe, where we have a network of Hyperloop. In this case, we found that the infrastructure cost must not surpass 30 million per kilometer, but even if we go up to 40 million euros per kilometer, it might financially work. The net present value of within the first years is going to be challenging. Maybe it's not going to generate much profit, but also this depends on the user acceptability, because as we said in the previous slide, this is a new system. That's why Hyperloop, except from the other parts of research, it requires state preference surveys in order to start exploring now what is the preferences and what are the factors actually that affect this system to be accepted within the transportation system by its users. In order to be more successful, the whole network should be operational. And this means that not only one link is enough, especially at the beginning, in order to bring up all the potential of Hyperloop. In terms of cargo, again, it can be used of course, as we said, for fragile commodities. And at the beginning, it can be a key player only for freight material transport. The deliverable closes with future steps. My colleague is going to give more details about the roadway, of course, and transferability. But we close the deliverable with some recommendations that are the result of a two-stage analysis for short-term and long-term gap analysis in regarding Hyperloop. So some certain focal points that can be identified is establishing a common framework, setting up the foundation for implementation, continue, of course, research and development, knowledge sharing, investing in a long test track in a real scale, a full scale, securing financing, going into transportation planning, simulation, and develop models that are now at the moment is easier and more feasible to have agent-based models at this stage, and gradually start bringing up transportation engineer standards and guidance in order to build the infrastructure system that Hyperloop requires. In closing, there are global vision all over the world from different companies, stakeholders that are engaged into the Hyperloop. We can see that more routes are coming up and this is something that we would like to see in the future in order Hyperloop to be part, not stand as a fifth transport, but actually be part of the transportation system and improve the whole intermodal transport chain at the global level. This concludes my presentation. Thank you very much.
Thank you very much, Lambros. All this information you will, as Lambros said, you can find in the deliverable that is in our website. Thank you, Lambros. Now it's the turn for the next speaker. That is going to be Jaime Tamarit. Jaime Tamarit is he has been working until 2001 as a director of the Physics and Electronics Department of CEDEX, that is a research institute of the Spanish Ministry of Development. And also until that time, he was fully devoted to the coordination of the MSET project for the validation of the European Rail Traffic Management System of the line Madrid to Sevilla. Since then, the European Rail Traffic Management System has been the core of his work. He has been working in it until the update of the European Directive of Railways Interoperability version 2.3. In 2007, he returns to the CEDEX as director of the Railway Interoperability Lab. From then, he has been working in certification of interoperability and validation of the European Rail Traffic Management System projects for infrastructure and rolling stocks. And since 2020, he is nominated chairman of the 10th NLH GTC 20 on Hyperloop. Thank you very much, Jaime, for being here, and it's your turn. You have the...
Thank you very much, Maria Luisa, for your presentation. Good morning to everybody. Could I share my screen for my presentation? Okay, I would like to start my presentation remarking that the connection between HYPERNEX and the standardization committee of CENELEC for Hyperloop is quite strong. The major part of the partners in HYPERNEX are working also in the standardization process undertaken by the Joint Technical Committee for Hyperloop in CENELEC. I think we are collecting all the findings from HYPERNEX just to produce the first versions of the standards. To start with, I would like to have an overview on the Hyperloop opportunities and challenges to know the challenge that we have to overcome. The opportunities are clear. Hyperloop can replace air traffic for intercontinental displacements. Hyperloop promotes mobility connecting city centers in short time with efficient connections. Hyperloop is friendly with environment thanks to the electrical traction and levitation systems. The technology is already available. Hyperloop helps the decongestion of roads and airports, and highest safety levels will promote industry development. Having a look on the challenges we have to face, the main challenges are the need of convergence of different technologies which are now under test. We need to have common safety approach. We need common risk identifications and hazards control science system conception. We need interoperability to foster an open multi-supplier market. We need infrastructure design allowing comfortable, non-compensated acceleration for speeds up to or higher than 1,000 kilometers per hour. We need to solve to face the problem of power supply to both at those speeds. And then we need to overcome to be the winners in the intercontinental competition. We need a unified European frame in the world of emerging markets. Look at China and Korea. And the time to Hyperloop in operation is not short. In any case, standardization work helps to overcome all these challenges. What are the requirements to overcome the Hyperloop challenges? Let us know, and to help, let us know what are the basic requirements. 3 basic fields: safety, interoperability, and time to market. Regarding safety, safety requires a common safety approach for Silver systems. It's a need of sharing risk identifications and hazard controls and system conception, and this must be made in common by all stakeholders. Interoperability. Regarding interoperability, within the technical field is a clear need of convergence between different approaches. There is an added difficulty due to the different status of development of different proposals, which go from applied research to pre-industrial testing facilities. The harmonization of safety and technical aspects and interoperability requires the engagement of all Hyperloop developers and industry. And regarding the operational harmonization, we need operational harmonization in the continental frame, and that requires the engagement of infra managers and operators for passengers and goods. And regarding the time frame, I estimate 15 years to get Hyperloop in operation. To overcome all this, we need support with human and economic resources. standardization process provides the required engagement of resources. The then standardization process provides the required engagement. The CEN-CENELEC Hyperloop Joint Technical Committee for Hyperloop, Committee 20, is approved by the CENELEC Board of Directors, is established and running. The basic technical structures to face the standardization process are established and running. The two first specific working groups are approved by CEN Board of Directors and are already working with defined time frame. Two conveners of excellent to manage both working groups have been accepted. Juan de Dios and Bobby from the Polytechnical University of Madrid and Fabien Letourneux from SNCF Research Department. Experts coming from operators, Hyperloop developers, and industry are appointed to work within both working groups. And the 5 areas of work items, are already created and running. The first one for operators and services that are going to produce a report, a standards inventory roadmap, the reference architecture, we will produce a standard, the general requirements, and vocabulary definitions. And you can see all these areas of work are strongly linked with the findings of HYPERNEX project. We are absolutely in line. We need to work in common. HYPERNEX for me is a good example of consortium to join the effort. Let us now to know a global sort of overview on the number of Hyperloop projects running and the resources and the status of development. You will see projects going from applied research to pre-industrial applications. All these projects are already working and engaged inside the Joint Technical Committee 20 for Hyperloop. A technical conversion of the proposal is needed. To reach this, a consortium of all Hyperloop promoters could foster it. This is a clear overview of all the huge amount of resources which are devoted to the development of Hyperloop. What we need is to work together, to have a common consortium joining all the proposals. In addition, we have observers from key European institutions like DigiMove, Shift2Rail, the CENELEC Joint Technical Committee 256 on railways. They are taking part in the plenary meetings of the Hyperloop Joint Technical Committee of CENELEC. Just to finalize, I offered you here a block diagram of the CEN Hyperloop Joint Technical Committee already settled and working. Probably after approval by the Joint Technical Committee 20 and having the required resources, a new working group devoted to the harmonization of new technical areas will be created. We are going to have a plenary meeting tomorrow with all the stakeholders in CEN-CENELEC Joint Technical Committee 20 for the Hyperloop, and I will advise to create, when convenient, a new working group devoted to safety. Thanks a lot for your attention. That's all.
Thank you, Jaime. Thank you very much. We have time for questions. Is some of the attendees wants to ask something to Jaime Tamarit about the standardization? Har said that Flora Gaspi from Har said that the hardware from the Netherlands is missing in the slides, and Har is an active member of the GTC 20. That's well. Thank you, Flora.
Hi, Flora.
What did
You're
you-
welcome to all these kind of meetings. You are always very active. Welcome.
Jaime, how do you see safety and compatibility in
I am coming from my experience with ERTMS. I have to say that we raised by 1 million or one order of 1 million the order of safety in the railways using ERTMS. And I think that at the beginning were different approaches. We started with 9 companies, we joined together, and then working together, we got the most safe product in the market. There is no new project not using in the high-speed transport, railways transport, not using ERTMS now. It's the safest specification in the world in this moment. And I think we have to take the findings from ERTMS and to enlarge to be applicable to Hyperloop. There are a lot of things which are profitable, like speed control.
what are the main risks to produce a standard?
Well, for me, the main risk is the lack of convergence between proposals. I think we need to put together all the stakeholders and to come to a common proposals promoting interoperability between infrastructures and both. By the moment, we have different proposals for tractions. There are synchronous motors, asynchronous motor, reluctance motors, and then there are different proposals for levitation, attraction, repulsion. And then I think we need to define a common tube diameter, the specification for vacuum. There are things that everything is solved, is available, but we need to choose the best proposal. But this must be done in common. And for me, another problem is that some projects are very near to commercial deployments, and other projects are in the research, applied research level. And then it's not going to be easy to come to a common proposal. But you have to do. HYPERNEX is a very good example. You have to continue.
We need to continue doing this teamwork, no? To
Yes,
the
yes,
best
yes.
product. We have a comment in the chat from Matthew Smithgood. He said, I would like to ask about a writing list of project participants involved in Hyperloop vehicles development. And if it is possible, direct contact between engineer and leader. Well, I think that we can answer. It's not a question to Jaime.
No, but Maria Luisa, this is just what I did in my last slide. I took all the Hyperloop developers which are engaged in the standardization process, and I show the status, what are the developments with pictures. But in any case, if Mateus wants to contact the Hyperloop promoters and developers, contact me and I will put you in contact. also with you, because all the developers which are working in the standardization process are also working in HYPERNEX. We are strongly connected.
Yes, yes, we are. It was said that all the stakeholders, the list of stakeholders are in the deliverables, and also we can provide the persons that are working.
I have to say that a project like HYPERNEX and the willingness to converse within going to focusing on standardization gives me hope on success.
Thank you. We have other question, that is, what is the interaction from the GTC 20 to rail actor and aeronautic actors?
No, it's clear. We need to define an infrastructure on which, inside which different pods from different suppliers can run without any problem and at the same level of safety. This seems to be trivial, but it's really, really difficult, because behind this is all the certification process. Certification of interoperability requires reference laboratories like FedEx, for example, which is the best in the world. And then we have been pioneers on interoperability. Spain is the best example. We have infrastructure from all suppliers in an open market, and we have trains from all suppliers also in an open market. To get this was not without problems. It's clear that Renfe and Adif were suffering on the consolidation on the commercial lines, but now it's really consolidated, and I think that Spain provides a very good support to interoperability in the world.
We have a comment from Marek Pavlik that he said that we are using interoperability as a term taken mainly from railways. This, however, needs to be precisely defined. Therefore, Marek proposed to define hyperoperability.
Yes, but you see that there are also work items in the standardization committee which are really working and progressing with a time schedule already defined, well defined, and then they are producing the first identification on the operational requirements for goods and passengers. And from these requirements, we will define later interoperability. For this reason, I say there are going to be new working groups inside the standardization process. The first for safety and the second for interoperability is clear. Are going to be, but by the moment we have 5 working group work items, and then we have a huge amount of resources. I forgot to mention that we have more than 100 experts already working on the standardization process. And then this reveals me a clear volunteer of convergence by all the engaged bodies. There is a willingness to converge, but now with the human resources we have, we cannot stand by the moment to additional working groups. We need more majority, maybe. I am going to propose this in the next plenary meeting of tomorrow. It's clear.
So now, in your opinion, Jaime, when we would see the first Hyperloop working?
Well, according to my experience, if the economic and human resources were available, then I think that the first could be in 15 years.
15 years, wow.
It's optimistic.
Oh. It's seen a long time.
No, keep in mind, regarding ERTMS, the European Rail Traffic Management System was based on road rail transport. It's a conventional improved infrastructure. and to the harmonization, because there were more than 15 national systems, and to break the borders took 15 years exactly, and was a more traditional mode of transport. But in this time, we were breaking the borders. Now the borders are open, I hope, are open for Hyperloop.
Okay, we have a question from Carlo Borghini. It's about that. How it's possible to imagine one infrastructure to accommodate different vehicles based in different technologies. Well, it's a creative. We have to put a lot of creativity in that.
This is exactly the question. For this reason, the Hyperloop developers have to converge, have to create a common consortium and to propose a common solution with common propulsion system, common levitation system to make everything compatible, interoperable, and open market. Open market is a great benefit for industry. HYPERNEX is one of the best examples. All the companies working in HYPERNEX are having projects all around the world. I am teaching some of them.
Okay. Well, Jaime, always is very, very interesting to speak with you.
Thank you.
For your clarity in your exposition. And now we have to follow the agenda.
Thank you.
We will have some time after the round table, and maybe if someone have more questions to Jaime, maybe he can answer in that moment. Jaime, thank you very much. Now is the following the agenda. Is the time for speak about the technical specifications in Hyperloop. Stefano Ricci from Università di Roma, from the DCA department, he's going to make the presentation. Stefano, when you want.
Okay, good morning to everybody. I'm trying to share my screen. 1 second.
Did you have a problem?
Hopefully not. I'm trying to do this. Let me know if it's fine.
Yes, we can see it.
Just try. If I move to the next slide, this is working. Now the second.
Yes, we see the second,
Okay,
but we see in the PowerPoint mode, not in the presenter.
Okay, I will try with the presentation now. And we'll see what happens. Switch to the second one?
Yes, perfect.
Okay, perfect. So, okay, so thank you. Good morning to everybody. I just introducing you to this aspect of the HYPERNEX project. It's technical specifications, so it's obviously a huge, field. The topic has been developed into HYPERNEX with some kind of collection of information that were available, because obviously the project is not focused on the development of new technical specification, not new technical systems, but just to try to create a framework of information about all what is trying to depict the potential scenarios for future Hyperloop startup and development. So there are many topics. Just to say, the original focus was on some issues like acceptability and adaptability of concepts from rail knowledge, because obviously we are in shift rail and the shift rail umbrella, so obviously, so this is the main issue. And then also to try to create some visions about common technical challenges for freight and passengers interoperability. This is another issue, potential function in terms of interoperability, and also what we are already speaking a little bit about for standardization and convergence with hazard analysis methodology and what is already in place in these fields for to make possible the regular and commercial operation of the new systems in general, and obviously in this case systems based on these innovations. So this is the work was divided in 4 parts. That were one is about the concepts of guided transport modes, Hyperloop and other systems. Hazard identification and safety cases analysis was another big part. Is the study of all potential, not all. We try to identify, based on the documents and what is already available from the developer, different initiatives and projects and programs, to identify the potential hazards or related with the operation, related with the single components, the vehicles, the infrastructure, and so on. And then technical components of the architecture has been created as put together into a description, entering into the details that are obviously in some cases not very deep, in some other cases a little bit more. There is obviously this homogeneous level of development for the different technical components. In some cases, there are very just ideas or just some kind of requirements, but in other cases there are more developed and tested components. Finally, this fourth part is about the concept of the operation, the Hyperloop integrated with other transport systems. So everything is in the deliverable 3.1 that has been developed in the first version in September, and the last version, revised version, just a few days ago. For the part number 1, so for the innovative concept in general for guided transport systems, the idea was to create a review of this, to analyze this concept, to compare a little bit about performances, and so this is just something that was already done in some studies, but the idea here was to put together everything these studies and try to create a more comprehensive overview about these potential roles of all, not all, but the most important systems with the common target potentially to be used both in freight and in passenger, and on the other side also to have chance to have operation at a very high speed. So it is something that was developed concerning high-speed rail, of course, but also maglev and other previous experimentation of systems, and obviously also commercial application of systems. With the plan, with the aviation on the considered too. So as a potential competitor and as a potential system that could be both competitor but also integrative, if in some at least in some concepts. The point about the hazard identification and the point about safety in general was including a lot of analysis about regulatory and general standards, both voluntary and mandatory. So that are listed here in the slides. Another point that has been considered in the market acceptance under safety conditions. That is obviously another issue with such disruptive methodologies. Is not the acceptance itself is not so normal or so it should be considered, because the market themselves are not open, and not only the market are not open, but they are also not aware of potential of these systems in comparison with others. So This framework should be created. So has been developed a methodology for risk analysis, identification of hazard. The hazard lot itself has been created, dedicated for all hazards that have been analyzed, that are concerning guidance, power supply, communication, interfaces, control and command, the vehicle itself, infrastructure, terminal and station, signaling. So the chapter, and there obviously are many, and but the preliminary analysis of potential hazards have been very careful, and there's been created a large amount of them according to a methodology that is also depicted in this picture on the right. And has been obviously dedicated a specific focus on also environment aspect and the interlocking aspect. Okay, is a part of signaling, but for stations specifically, environmental issues, the evacuation problem that was a key issue for safety. And but all these aspects has been also qualified with identification of future research. So the most important future research topics that need to be developed in the future. So obviously it's a review project. The most important thing is also to identify next steps. I have a problem with the slides. It's not going. Sorry. Try to. It remains that this slide is not moving to the next. I don't know why. Just.
And change to the PowerPoint mode.
No. Yes, I do something again. Back to the. I try to restart the share. Sorry, 1 second. Perhaps it's. Okay, yes, now seems that it's working. I don't know if you can see. Hopefully, yes. So the part of number 3 was the architecture. So it obviously this isn't something that does not exist as a system with the well-defined architecture. As you can imagine, there are many different approaches. But the idea here was just to compare approach and try to identify common aspects, and so common subsystems in this architecture, and also differences. So Hyperloop infrastructure were compared, first of all, with other transport modes, and then each other. Obviously, the main subsystems were obviously the infrastructure, the vehicle, the control and operation, propulsion system, the communication is another option, with a high specific eye on energy management, and electronic systems, and have been also considered. But the idea here was to creating again a panel of what is on the table, and the effort was mainly into identification of what is different in different potential application or project or ideas, and also what is motivated from what is already working in other railway field and in other one. The last chapter was the last part of the work was creating some kind of operational analysis about the concept for the intermodality, so visions of which could be the role in comparison with other, in cooperation with the other transport systems of Hyperloop. And a specific aspect was also the operational management of risk. So not the risk analysis is another chapter, but what happened in case of accidents on the, or not really accidents, disruptions in general, for the management of the risk that is obviously new in this field. But it's also dedicated, we dedicated some analysis in this chapter, particularly to post-operation review, decommissioning impacts, environmental impacts, and so on. So it's another aspect that has been developed here, because the idea is that the system should be also analyzed, of course, as a life cycle, in a life cycle vision. So it is important also this aspect. So this chapter is also closing this part, and so is closing also the analysis to the aspects that were not considered before. Okay, we have again this problem with the slides. No, yes, now it's fine. It's working. So conclusions and my achievements. I just try to summarize in 4 points, more or less, in connection with the part of the work. So the first one is now we have created an exploration of the various high-speed transport modes and with a more systematic comparative analysis, also from the viewpoint of the functional legal aspects, both in freight and passengers. This is a second part on the safety. This is another achievement I think is very important, because the hazard analysis were very deep and were very careful and very comprehensive. So obviously nothing is complete. The system is not yet mature to be developed. The system, very, very detailed analysis, but the framework in this case is, I think, is very well built and could be easily applied, moving to the more details and more maturity of the project. The technical elements have been now collected for what is the state of the art, of course, and there are also some kind of analysis that try just to focus on what is more or less consolidated. So what is from the different projects and proposals is more or less in line, and in some other, but also to highlight the situation in which there are differences, and of course research areas to be developed for also in the light of the integration in the network, in the intermodal network. And the last point is the operation that is so it is directly connected with this. So in which way this could be integrated in the more larger network, but also in which way it could be bringing relevant positive effect on environmental impacts, and also more cost-effective maintenance and decommissioning procedures, because obviously create new infrastructure, new system like that cannot be considered without having an eye also what happened after the system is no longer working, or at least single components of the systems are no longer working. So this is more or less obviously the overview of what he did at a high level, but for some aspect also a little bit more in detail. That's all from my side. For any questions, I'll be happy to try to answer.
Okay. Yes. Thank you, Stefano. Thank you very much for your presentation. I think that we have a comment, but I think this about the previous concept about interoperability. So if we can leave this question at the end of all this section about HYPERNEX, and maybe Jaime Tamarit could answer in the questions and answer section. Thank you very much, Stefano, for your presentation. And now it's the turn to Luz Celeros Luz Smith from Celeros. That is one of our promoters partners, and she's going to present the work package 4 and the deliverable about transferability and the roadmap beyond HYPERNEX. Luz.
Hello, everybody. It's a pleasure, and thank you very much, Maria Luisa. Now I will try to share my screen and cross fingers. Everything works okay. Let's see.
we can see your screen.
Okay, now I will try the presentation mode and are you still perfect? Okay, so let's start. I'm going to present the last deliverable of the HYPERNEX project, and this is as a conclusion of the two previous deliverables. I think the organization of HYPERNEX project is a general overview with the observatory, then specific aspects of safety and requirements on Hyperloop, and now a final vision comparing with the existing transport modes and the integration of the future Hyperloop transport mode into the existing environment. So the objective for this last working package is to identify the synergies between the existing transport modes and the Hyperloop, and also to define or to look for a first approach for the standardization necessities, the regulatory framework, and the possibility of being incorporated or taking profit of existing funded projects to help the development of the Hyperloop concept. So the final goal of this working package will be a deliverable. I think it's important to highlight again that all the deliverables from HYPERNEX project are going to be publicly available. It's important because we are trying to fix a general framework and the state of the art of the Hyperloop, the concept of Hyperloop. So it's important to have this all this documentation and all this research in an available document for the rest of the society or whatever may be needed. So this final document is organized in three main parts. One is the link and the relationship with the guided transport modes. That seems to be the more similar concept to the Hyperloop. So the first approach is with the existing guided transport modes, then with the opportunities within the non-guided transport modes, and then a final analysis on the potential regulatory framework, standardization, and certification, assessment, and those collateral developments that need to be put in place in order to have a real system in the real world. So how we have structured the document in order to provide these answers. First of all, we have prepared a taxonomy of all the existing transport modes and define a value chain for all of them. Then we have defined more specifically the guided transport and the non-guided transport, and we have analyzed the current and future trends of guided and non-guided transport, the existing programs, the synergies, and the cross-fertilization opportunities. And finally, an overview of the standardization and regulation framework, including regulatory practices, vision for assessment bodies and notified bodies, and the standardization opportunities. More in particular, it's one of these chapters are going to be developed in the next slides. So first, for the transportation modes and their taxonomy. a very deep analysis of all the transport modes for land, for air, and for water have been made, and we have approached taxonomy as a categorization and a hierarchy of the different systems and subsystems, or transport modes, I may say, and then define the scientific principles, the different methods, the classifications, in order to have what is a taxonomy. Okay, first of all, in a general overview of guided, non-guided, land, air, water, and whatever transport mode, in order to have the full photograph of all the transport modes. Then we have prepared the different specific issues for every one of these to pass from the classification to the specific characteristics. So there's a definition, an explanation about the different features in an operational way of the different transport modes, classification, and then we have also included a first link to the circular economy. HYPERNEX project was approved under the Shift to Rail 2 years ago, and in between, a new taxonomy for the transport has been developed and approved by the European Commission. That taxonomy is related directly to the sustainability, circularity, and environmental impact of the transport modes into the environment. So we have taken this new approach, and we have done prepare a first approach that probably would be good to have a further development on this sense. But we have to take into account that the general framework of HYPERNEX belongs to the previous Shift to Rail and regulation in place 2 years ago. But we have to, I think it's a must to include this concept that is, I think, a little bit revolutionary for what taxonomy is, and in particular in transport. So we have made a first approach. Then for the current and future trends, we have started the division between the guided transport and the non-guided transport. For the guided transport, there is a study or a development on the different guided systems, the trams, the subway, the train, conventional and high speed, and so on. For each of these different transport modes, there is prepare a short technical overview, a legal overview, and a short information about the current status and the potential future trends. Once we have prepared this general overview of all the guided transport modes, for the future trends, it has been based mainly in the future trends related to regulation and standardization. To have for the relation with Hyperloop, I may say, to have Hyperloop in the future, we need a general framework in which we can move and we can feel more than comfortable, I would say, safe. We know the rules and we know what is expected from the stakeholders related to the Hyperloop system. So a complete analysis in relation with the existing transport regulations and how they could be applied or modified to have application to Hyperloop. In that sense, there is even a proposal for potential essential requirements that would define the general requirements of the Hyperloop system. And also a proposal or a study, I may say more than a proposal, on the different assessment and certification processes that are now in place and that could be applicable to the Hyperloop system. Dealing with the next issue, that is the synergies with the existing technologies and also with the existing joint undertakings. This deliverable has been focused in the shift to rail. Now we have the European Rail Joint Undertaking, but this project is under shift to rail joint undertaking, and we have prepared a relation and an overview of the potential synergies between Hyperloop and objectives under the shift to rail framework and the shift to rail projects that have been developed during these years. So shift to rail is mainly focused in railway. There is a existing technology, and this joint undertaking is aimed to promote research and innovation, and there is a huge possibility for a Hyperloop to be integrated and to give the same response to the same objectives to these research and innovation programs. So an analysis of the different opportunities, capacities, and demonstrators under shift to rail, and a step-by-step analysis of the different innovation packages has been made, and an overview on the synergies between shift to rail and Hyperloop has been prepared. It's a very exhaustive work, and I may say very interesting. When preparing this part, or when reading, because I have not prepared, I'm coordinating, it has been very, very interesting for me. Then we go to the non-guided transport modes. There are quite a lot of synergies also with other transportation modes, non-guided. Maybe it's not so easy to see at a first glance, but there are common technologies and common objectives. For the non-guided transport synergies, a new vision has been made. More than identifying technological aspects, we have identified more, I may say, not philosophical, I don't know how to explain, but a more general vision. The impact also with the economical, the environment, the possibilities for new businesses and cross-fertilization between different industries and creating different businesses and cross-fertilization of knowledge. I think one of the most important conclusions, I will say afterwards, is that the possibilities of taking profit of what already exists by the part of the Hyperloop, and to take profit of the innovations for the existing transport modes, it's really an opportunity for all the transport station system, not all for one part or for another. So finally, the last chapter of this deliverable is related to the specific analysis of standardization and regulation. We have made a first approach in the state of the art and the opportunities chapter, but in this close we are more related to the European standards and specifications and its relation with the regulation. We have seen that there is a standardization committee in place, and Hyperloop as a new transport mode can take profit of the benefits of standardization for industrial point of view, from a future commercialization and trade facilitator point of view, for a open to new markets point of view, and for a business point of view. So there are quite a lot of benefits, not only for the developers of the Hyperloop, but also for the regulator, for the operators of the infrastructure, for the managers of the infrastructure, for the future industries that are going to be tiered to this Hyperloop transportation mode. It's a lot what already exists, and that can help to focus Hyperloop on what needs to be developed. Standards and regulations, the proposal is to have something similar to what is known to the new approach, the way of regulating of the European Commission based on essential requirements, rather than fixing technologies and specific technical requirements. And then an overview and the proposal for how to assess the necessity or the possibility of defining notified bodies, certification procedures, and so on. And then the specific, first a general overview, and then a specific approach to the Hyperloop necessities. In that sense, it's important to know that already is in place. Jaime Tamarit has already mentioned it, a standardization technical committee since Senelec 2020. And these are the 5 work items that are under development. All of them are the basic lines for all the future standardization program on Hyperloop. And it's important, related also with this cross-fertilization and synergies, the work item that is going to be a technical report on the standardization inventory and roadmap. We can take the reference of many standards. There is a huge catalog of standards in SEN and Senelec that are going to be the base for our HYPERNEX defined technologies. I may say that Hyperloop is taking existing technologies and using them in a disruptive way, but what is existing we have to use, and what is non-existing we have to develop. So that's the clear next steps in relation with standardization and with regulation. As conclusions, I may say that Hyperloop is a new transport mode that can provide answer to specific necessities not solved but by other transportation modes and necessities that are in the societal agendas. I mean, for the citizens, for the transport of goods, for the European and best way of life, but also in the political agendas in relation with the environment, with the climate change, and this new taxonomy of transport. There are a big amount of opportunities. We have to look for the synergies and for the cross-fertilization with all the existing transport modes, not only guided, that is the more direct one, but with also with other also. For example, we are going to have autonomous driving system for all the transport modes, not only for guided, but also for road and even for maritime. Communication is changing every day. The needs for signaling and commanding between in this case for guided transport is a must. So there are quite a land of synergies and cross-fertilization opportunities. That is an opportunity for all, not only for Hyperloop. There are also open points. There are open points that need further development. During the HYPERNEX project, not only in this deliverable, there are some points that are highlighting that further research and funding projects will be necessary in order to continue and to progressing. And it's important to see that Hyperloop has a specific space into the existing funded programs from the European Commission that is providing answer to the specific objectives of the different undertakings. And for regulation, we need a regulation in time if we think that if we want that Hyperloop can be in place by the 15 years, Jaime Tamarit already mentioned. We need the regulatory framework, but not only the regulatory framework, but to this regulatory framework to be in time. And a standardization roadmap in order to help to this regulation to be put in place and not to invent what already exists, not to redesign the wheel. The wheel exists, and we have to provide efforts to the issues that are open points and needs additional research and resources. So that's all from my side. Thank you very much. I give you the control, Maria Luisa.
Thank you, Luke. Thank you. Thank you very much for your presentation. We have well, 1 minute if someone wants to make a question or something like that. I don't know. There are some comments in the chat box related to interoperability.
I have forgot to say, and I had a very big letters here after Jaime Tamarit, but I didn't read the my post-it. One of the conclusions is that first is the need of safety, and then we will seek for the interoperability. But one of the conclusions of HYPERNEX is that safety is first.
Yes. We have to demonstrate that Hyperloop is completely safe for, especially for passengers, of course.
I fully agree, Ruth. Thank you.
Okay, now, if we don't have any question in the chat box, we are going to give a coffee break. So let's come back in 10 minutes if you agree with that, and we will start with the roundtable. So thank you very much. In 10 minutes, we come back. Thank you. Good morning to all of you. I was presenting the roundtable. That is the part that it's going to listen in the in the next section. Now the roundtable is about next steps beyond HYPERNEX. And in this roundtable, we will have as moderator Juan de Dios Sanz, and the panelists are the following: Carlo Borghini from the EU-RAIL Joint Undertaking, Konstantinos Koumas from the GRC, Torben Holban from the IRA, and Leonardo Da Giovanni from the DG Move. Let me introduce a few words of Juan de Dios Sanz. Juan de Dios Sanz is a professor in the GPM with 30 years of dedication on the railway research. First, he works in industry, and since 2006, he started to be a faculty of our university. He is one of the members of the Advisory Council of the Spanish Railways Technology Platform, and in the same GTC 20 on Hyperloop, he acts as convener of the working group Hyperloop Operations and Services. And in 2018, he joined as an expert in transport and logistics under the Spanish delegation in the United Nations Economic Commission for Europe. And since 2014, he participates in the Chief Rail Scientist Committee. So, Juan, I give you the floor, and let's go with the roundtable.
Thank you very much, Maria Luisa. Welcome to the next step beyond HYPERNEX session. First of all, thanks to the consortium for this kind invitation. And without more extension, let me to introduce the panelists, helping you to understand who is who. Leonardo Da Giovanni is a policy officer in DG Move, Rail Safety and Interoperability, and he joined to the Commission in 2017, and under his role, he is currently in charge of a number of innovation-related topics such as Hyperloop and the European Digital Automatic Coupler Delivery Program, a very good impact in the freight transport in Europe. He has a degree in environmental economics from the University of Pescara, and after a traineeship at the United Nations in Vienna, Leonardo took a postgraduate master's degree in environment, marketing, and quality at the Strategy Business School in Rome. In 2008, Leonardo moved to Brussels to work as a political advisor at the Association of European Rail Infrastructure Managers, dealing with environmental uses, European funds, and TEN-T. Before joining to the Commission, he was Public Affairs Manager at UNIFE, the Association of the European Rail Industry, and Executive Secretary of the Rail Forum Europe for 6 years. Our second panelist is Konstantinos Koumas. He is a program officer at the Sustainable Transport Unit of the European Commission's Joint Research Center. He is involved in the development of tools and methodologies to advance the analytical capabilities of the European Commission's Transport Research and Innovation, Monitoring and Information System, TRIMIS. Within this, he focuses on transport infrastructure, connected and automated mobility, and new and emerging transport technology. He holds a master's degree in engineering and his doctorate in transport from the University of Rome, La Sapienza. Since 2018, he is representing the Joint Research Center in meeting on Hyperloop with promoters and member states called by DG Move, and his main focus is mapping technology development. Torben Holben is analyst team leader at the European Union Agency of Railways. He joined to the agency in 2006, and in his current role, Torben is leading the agency's work on economic analysis, impact assessment, and ex-post evaluation, as well as coordinating the agency's monitoring of the European Union rail system regarding interoperability and safety along data and information analysis. Before joining the agency, Torben held research positions at several UK universities, most recently with the Transport Studies Unit at the University of Oxford. He obtained economic degrees from Copenhagen University and European University Institute in Florence, where he achieved the doctorate. Torben has more than 25 years of experience in applied economic analysis with particular focus on the rail transport sector. And our fourth panelist is Carlo Borghini. Carlo Borghini was appointed Executive Director at Shift2Rail joint undertaking on 16 February 2016. And he is responsible for the overall management of the Shift2Rail joint undertaking activities. Since 3rd November 2021, with the establishment of Eurorail joint undertaking, the universal successor of Shift2Rail, he continued in his role of Chief Executive of the new partnership. His mandate has been renewed till May 2026. Then, here is the presentation, and thanks all of you for your participation. Now, I'm going to introduce the discussion of our session. As it was discussed in the previous session, HYPERNEX is a contribution to get a formal understanding of Hyperloop maturity, one of the keywords, a state of the standard and safety approach, and possible action linked to the rail actor constellation. But from the perception of the society and the audience that we are here, we have to take attention to the whole European transport and mobility community in two main aspects that we want to introduce for our debate. From one side, the doubts concerning the operation of the system, the timing to get a state more advances than a conceptual design in a real environment operation. We are speaking about technical research level 8-9. Issues about safety, approval, and authority, interoperability between Hyperloop infrastructure and compatibility between technologies in the same infrastructure, the services and the interfaces to other transport, but also an extended idea about the possible cannibalization for large range rail services. The other side in the community is the opportunity for achieving a new transport system using an efficient use of the resources and services from the design, including starting a perspective over the basis of circular economy example to apply in the whole life cycle as possibility for capable sustainability, without the general overview for the Hyperloop integration in the existing transport system. Then, I have a clear question for you, and I kindly ask for the audience to use the chat to make your question to the panelists. Then my question is, can you share with the audience what is your vision of Hyperloop in Europe? How do you understand the necessary priorities and what are the actions ongoing or planning from your institution? Then, thanks to the panelists because they want to share a presentation. Let me to share the screen. I think you are seeing the screen. Then, one moment to be higher. Then, Leonardo, can you start with your?
Yes, thank you. Thank you, Juan, and good morning, everyone. Yes, you can leave on this slide. Just a few words of introduction from a commission point of view. I attended part of the first part of the conference this morning, and many things have already been said, and many things have already also been put on the table by Juan in his introduction. From a commission point of view, of course, we follow with interest the development of this new technology. Just to mention two very concrete examples, Hyperloop was mentioned in the Sustainable and Smart Mobility Strategy of the European Commission, which, let's say, sets the policy for the coming years, and in particular, the need to develop testing and a regulatory framework. And more recently, at the end of 2021, Hyperloop was also mentioned in the Commission proposal for the TEN-T revision. of course, rather as a placeholder for future development, but this is something that is happening for the first time now. So this shows that the Commission is really looking at Hyperloop as a possible transportation mode of the future. Why are we doing this? Well, the environmental advantages have already been mentioned, and the idea is to promote Hyperloop as a low energy and carbon neutral transport mode. Of course, this goes also in parallel with the greening other transport modes, namely rail and also other land transport modes like road, for example. And this is one key advantage. Of course, we see also a strong interest from the sector, and we work hand in hand with a number of promoters, with 7 promoters, both European and non-European. I see some of them, if not all of them, around this virtual table today. And we are really working together to progress in this respect. To also start the discussion, I would like to mention 3 different layers of current and future work. One is about, let's say, regulatory aspects. This is probably the key area of work of the Commission. It has been discussed extensively with promoters, and now the idea is also looking at the timing for the development of Hyperloop, to start working on an impact assessment for the development of a regulatory framework already this year, possibly have a Commission proposal in 2023, and then aiming at finalizing discussions also with Member States and Parliament in 2025. This is our plan, based on also discussions with the promoters. Of course, it's not set in a stone, but the idea is to move on concretely in this direction. We will discuss, I think, later on what should be in this regulatory framework, but some elements such as safety and interoperability have already been mentioned today. Then, of course, there is the technological path, and this is very much in the hands of promoters. We are following this, the developments. We see that there is also a plan for further testing. In one of the previous presentations, it was also mentioned the fact that some additional test tracks are in the pipeline, which is good. Probably here a decisive step, or let's say natural selection, will be made once we have full-scale demonstrators on long distance, which is not the case yet. So this will probably, in a way, guide also the technological development. And then, last but not least, to also open the discussion, we should not forget the investment part, because if you have the technology, if you have the regulatory framework, but you don't have the investment, then you end up with an empty shell. And this is also key in order to, let's say, have the Hyperloop really running in the future. Let's see if it's in the near future. So the combination of these 3 elements running more or less in parallel, of course, there may be difference in terms of speed, will then lead us to the development and the deployment of Hyperloop in the future. So we are working on these 3 aspects. We're working very closely with the promoters, as I said, and also with Member States, especially for the investment part. And this is really helpful for us in order to see where we want to get in terms of future Hyperloop deployment. Thank you.
Thank you. Thank you very much, Leonardo. Please, Constantino, do you want to give your opinion?
Yeah. Again, thank you very much for having us here and for inviting JRC. I fully agree with Leonardo, who has set proper manner the scene for this discussion. I should say a few words about the JRC. We participate since the beginning, and the first meetings called by DG Move with member states and Hyperloop promoters So we have experienced firsthand the progress since 2018. And I'm to say from my perspective, at least, that a lot of progress has been done, considering that now we have a situation in which Hyperloop promoters can discuss with each other and basically break some silos that existed before. Just to say a few words about the JRC, I would say the scientific branch of the Commission, so we support the Commission with scientific evidence, so that the Commission can take the right policy decisions. In this first phase, we have supported it in some limited areas, but still we have given some expert opinion, for example, on underground structures and risk-related aspects. These are some other, let's say, secondary issues that need to be addressed along the path that will bring Hyperloop to the market. Another aspect I want to point out is international research and international developments. I mean, beyond Europe and beyond the usual suspects, I mean, the USA and Canada. There are other countries investing and doing research on Hyperloop. And this is something we identify also indirectly, because not always the communications are easy to handle. For example, in Korea, there is a lot of research, something that we have seen through academic publications that have flourished, especially in the past 6 months in the last 6 months of 2021, something that maybe is not captured by the first deliverable of HYPERNEX, and also a very broad patent in China. This shows interest, and to make sure that there is progress in Europe, we have to make sure that there is also progress and collaboration with international partners. Just some of the first points I wanted to touch upon, and maybe Torben can continue this conversation.
Yes, so I hope you can hear me. Okay, so it is afternoon, so good afternoon to everybody. I hope you're all well. Many thanks for inviting me to this panel discussion, and it's indeed a pleasure to be here today. Hope next time that it will be on site and not on virtual, but it's very good to see you all. A little bit of preliminary remarks in this start of the roundtable. First of all, the image that you saw earlier is when the camera is not on, is not mine. It's my son, who is a keen chess player. So just to mention that. As thanks for the introduction, I've been in the agency since 2006. So I'll not go into the detail of that, but I'll just highlight a couple of points on the agency and the role of the agency. The vision, first of all, is a sustainable, safe European transport system without frontiers. And the mission of the agency is moving Europe towards a sustainable and safe railway system without frontiers. Now, just a little bit of background in terms of what the agency is doing in terms of task. First of all, some of the tasks from early on when the agency was set up in the second railway package 2004, operational from 2005, promote a harmonized approach to railway safety, and also devise the technical and legal framework in order to enable removing technical barriers in the railway system, along with also being system authority for ERTMS and telematics, as well as also facilitating the improvement of accessibility and use of the railway system information. Then there is the fourth railway package with some new tasks, notably vehicle authorizations valid across Europe, single safety certificates and also ERTMS trackside approval. So that just provides you a little bit of very brief background on the agency. And I thought it was really interesting presentations from this morning. And I think one of the last presentation also highlighted the correspondence that is and the lessons that can be learned from railways into Hyperloop and other similar guided transport systems. And I think that's one of the main role why the agency is also present here. So I think in terms of what the agency is doing linked to supporting the reflections and evolutions of Hyperloop is first of all drawing on the agency's expertise in railways and also its authority role for certifying vehicles, certifying undertakings, and also linked to control command systems. Those kind of lessons in terms of procedures putting in place could be of relevance for the further reflections of the agency. And here the agency is a relevant source of inspiration with respect to the railways mode. Per regulation, the agency shall contribute to railway-related research and promote innovation. I think that's the main interface here. So just a couple of points similar to also the JIC, but also alongside other regulatory agency. The agency is participating in the Hyperloop Promoters Coordination meeting since 2019, and we have provided specific inputs on the railway aspects in terms of vehicle authorization, in terms of safety certification, and also, as was mentioned earlier, the common safety method for risk assessment that may also be of relevance in the evolution development of what is the issues linked to be taken care of when you develop a Hyperloop further. And I think one of the key points there was safety first as a key starting point. Then we can start talking about other issues like interoperability and multimodality. And apart from the participation in the coordination meeting, I have also participated in the advisory board of HYPERNEX and reviewed the different interesting and insightful deliverables. So that's a little bit of background to the agency and the contribution we are making to this innovative technology. Thank you.
Thank you very much. And Carlo, what is your opinion from Shift to Rail and now the successor in Europe Rail undertaking?
Good morning to everyone. Thank you, Juan. And I'm really happy to be here with you today. First of all, let me congratulate the consortium because the HYPERNEX project is a project of the former Shift to Rail. And I'm really glad that we had the opportunity and the board agreed to fund the HYPERNEX activities, and the consortium did an important job in this respect. Also a job that will be, work that will be part of the base that Leonardo presented in his picture showing regulation, development, and financing elements that will contribute to bring to the market the Hyperloop. Hyperloop for me has been, let's say, something that came back before taking my job here in Shift to Rail, still when I was working in traffic management. And it's something that I'm following up now maybe for something like almost 15 years. And I start to be a bit worrying also because it's a moment in which innovation need to start to move from idea and concept to enter in the market or start to demonstrate its positive. Leonardo mentioned before I took some words that he used about the sustainability element of the Hyperloop technology. That absolutely is one of the key elements that will promote, in addition to time reduction, connecting European capitals, possibly, or cities, or transporting goods in a fast delivery way, and maybe avoiding the experience that took place in the United States on the supply chain during the last year. But where we are today, this is the key issue. Today, I think we have a lot of projects going on. Well, the promoters are all committed, and we can see their investment, their willingness to move on. But at the same time, we don't have yet one real large-scale demonstrator of the Hyperloop technologies. And I think this is really where we start to face the risk associated to the introduction of new technologies. And I think here is where we need to work together in accelerating these processes. Also for Europe's rail, as well for, was mentioned before, for the Sustainable Smart Mobility Strategy, for the TEN-T revision, there is a clear reference to the Hyperloop technologies. Also in our multi-annual work program, we have a dedicated section that is called Flagship Area 7, that is linked to non-traditional and emerging transport system. But the key point is how we move from all this work we have done up to now, in the, formally in the last 3 years inside the context of Europe's rail supporting the Commission, or Shift2Rail supporting the Commission, and now to try to bring a new mode of transport, a new potential mode of transport to the market. I think this is what we are facing today. So when you are asked before, Juan, which is our vision and our, let's say, expectation or priorities in this respect, I think the priority that we need to have, at least from the research innovation point of view, is to accelerate the establishment of a research innovation framework that will bring to the market first a large-scale demonstrator to show the cost benefit of the solution. I think we need to accelerate this. I am not convinced, and I asked the question before in the chat, that one infrastructure is the answer, because I'm not sure that, as there are many of the representatives of the promoter around the table, that they will be ready to let's say, join and create a consortium, as was mentioned, and put them together, and fundamentally to have one solution. I don't think we can ask something like this at this stage. I know also, and I share what was said before, that clearly it's extremely difficult to fund 7 different possible alternative solutions, as most probably not in Europe and most probably not at global level will have the resources to do this. The question of interoperability is still on the table, physical, but also operational. So there are a lot of thematic areas into which we need to work. Safety, I think, for me, is not an issue, because without safety we cannot start the discussion. So it's really at the basis. So I watched yesterday night by chance a documentary movie on one channel. I will not make advertisement, but what happened with the 737 MAX. I invite all of you to look at it if you have the opportunity. So for me, safety is a sine qua non that should be there. So if I look at the rest, what I see is really at the moment, and this is really the priority that I would like that we have in Europe's rail, and is part of the Flagship Area 7 at the moment, is can we bring a large-scale demonstrator into which we can show at the world the benefit of the Hyperloop technologies? Would be for passenger or for freight. And maybe for freight is easier for different type of, clearly it's easier to deal with the box than clearly people. Although I would be happy to have one of the first tests, but this I think is really the major change we need to work on. And I think in the evolution of HYPERNEX, because HYPERNEX set interesting basis and the work was really professionally done, really we need to support the Commission in the task that the second priority is support the Commission in the objective that Leonardo mentioned, the regulatory framework, impact assessment, regulatory framework, The other two aspects are part of the work also Europe's Rail will be doing. And finally, the funding and financing will be the complementing top of this. Each of us is here with this commitment. We want to, in our vision, we want to support the promoters to succeed in this story. Whoever will be able to take the competitive advantage, and this story is clearly will be most probably materialize it earlier. But I think we are here really with the objective to support the promoters. It's a unique opportunity is offered. I believe that Europe has the knowledge, capacity, legal framework, recognition at global level to set up the Hyperloop as a fifth mode of transport or a new mode of transport. I'm not worrying at all personally on the possibility competition with other modes of transport. I think there is an opportunity for all to be present and to create and deliver these services. The key point that we need really to look at now is how we can maybe concentrate resources on the primary objective of large-scale demonstrator. I think this is really where we can we need to work on. And as Costantino said, I've been discussing. There will be tomorrow a speech that I've recorded for the Korean event in Seoul. Tomorrow morning will be presented, and I know they have a major investment in starting in Hyperloop technologies. Chinese run a major program, maybe not so known, and I think others. So we have worked a lot in Europe. We have worked a lot in Europe with other global partners. I think is the moment that we need to show. And in Europe, we are really very good to do research. We do studies, we do economic studies, we do all the elements. But otherwise, where we fail is to bring it to the market, to do the innovation chapter. I think this is the moment into which the next couple of years we need to bring and accelerate the change. And I don't think we need to wait 15 years. 15 years is too long. We need to do it with a much shorter time frame because after, yes, the commercialization maybe can take longer and so on and so on, but we need to have this key demonstrator achieved in a quite short time frame to support the work that's been done so far. Thank you, Juan. Back to you, and happy to answer any questions.
Thank you very much for all of you. For the audience, sorry, but the computer in which I was sharing the presentation was shut down, and I will share the presentation directly. You can access via the chat after the session. And now, please, we are the four main actors that can decide what happened in the Hyperloop for the future. Of course, the promoter has the key and the challenge to get the optimum. Please, Jorge. Please, what is your question, Jorge Iglesias?
Oh, okay. Hello, everybody. Hello, Carlo. My question is very simple. I fully agree with you, Carlo. It's the time to go to the market to make a real scale prototype to demonstrate the viability of the system. But my question is, there is a capacity from the European Commission of Europe Rail or any European institutions to finance this full-scale prototype, because it's a lot of money, and the problem of the promoters, they are startups and they don't have funding for this project. There is any possibility from the Commission to finance one of these real-scale prototypes? Thank you.
I don't know if I may answer directly, Juan, but I see you are nodding. Thank you, Jorge. There are two things. The first of all is that, yes, we have some budget available inside Europe's Rail for what we call exploratory research and other activities. I think in this budget, we can make use of resources. And second, when I talk with many promoters, I think we need to start to think about how they use the public money in a different manner and move away from the pure grants to the leverage effect. I think Hyperloop has a huge potential, and maybe we need to use the possible any money that will be available in Europe's Rail with the leverage effect that is maybe 20 times, so that it's becoming a bit of a levy to allow the promoters to consolidate the monies around this initial funding made available by the, for example, the JU or I don't know, the Commission. This I let Leonardo to intervene. But to create really the opportunity to do this. So imagine that we are able to invest, I don't know, it's a brainstorming, but imagine that the board would agree that we invest 5 million euros, 10 million euros, I don't know, in the Hyperloop. Can we create a leverage effect of 20 times? Because if we can do this, okay, at this point in time, we will have a budget of 200 million euros, bringing together funding from other sources, and we will have the resources to create the demonstrator. If we are looking only to have a project that is fully funded by the European money, I don't think we will have, let's say, the opportunity to materialize. Why I'm saying this? Because I will also call in this the member states. And I will say to the member states, look, Europe's made, well, once again, it can be Europe's rail, can be whoever is appropriate to do. As I said, the governing board in our case should have taken a decision on this. But imagine the governing board once again would agree to put money. Can we bring together the budget at the same level from 10, 15 member states, or maybe from the private sector, and making this happen? And we have the legal framework. In current Europe's rail, we have a regulation that allows contributing partners, for example. So it's a concrete. So it's not, I'm not talking something about theoretical, it's something really concrete. We have contributing partners that can come in to fund activities together. Clearly, the governing board once again has to agree, but honestly speaking, I don't see what is what would be the issue. And this will concretely make in the next 5 years something happening. So I would look at the idea of if we really believe on this, we need to change the speed and we need to change the way to do it, and maybe really sit down together with this type of objective. Thank you. I don't know if Leonardo, you would like to add something about it.
Yes, thank you, Carlo. If I may complement, I mean, I fully agree on what you said, and just to complement on this, I think Hyperloop, from its let's say beginning and initial conception, has shown some sort of let's say innovative mindset, and the same would apply also to the funding and financing elements, in the sense that if we start from the assumption that if the Commission will not fund the Hyperloop testing facilities or even the future testing Hyperloop network, this will not happen. I think we start on the wrong step. There are many other ways, and Carlo mentioned just a few: member states, private financing. Even the same promoters are in a way looking for alternatives, and we should explore them and not get stuck to the fact that the Commission should fund or finance all of it. So that's my complement to what Carlo said, which I fully support.
Thank you, Carlo and Leonardo, for your answer. It's very clear. Thank you.
Thank you. Thank you. Now we have in the chat two different questions.
Please, sorry, Torben Holman. So I think that
yes, Torben.
Yeah, just very briefly, I couldn't agree more with Carlo about the point on the importance of cost-benefit analysis, not only at the start, but also systematically to use cost-benefit analysis as this is being developed further. I think that's really critical to ensure the balance between benefits and costs. Thank you.
Thank you. There's any other comment for the question related to Jorge Iglesias? No. Then thank you. We have in the chat two different questions. And I think that they are aligned to the perception of that maybe from the Hyperloop, it was at the beginning as a kind of innovation program instead of a research and demonstration activity. So the question from the audience, from David Martin, and also maybe including Javier Gomez, is if any of you are thinking about the supersonic possibility of the Hyperloop, or do you see impossible for the moment and we need to walk before run?
Maybe I can try to answer this question.
Yes.
Basically, having a supersonic Hyperloop was originally developed by Elon Musk in his white paper in 2014. this also was discussed previously by my colleagues, and the cost-benefit analysis in the sense that it's not maybe appropriate to push the limits of these technologies, but maybe find a sweet spot so that we can have an operational Hyperloop that goes beyond an internet and maybe cost a lot less than pushing the technology to the edge. So I would say that this is not something we should focus on now, because pushing the limits could be something that would lead us to solutions that are not affordable and viable in the long term. Still, the testing and the development will take a long time. For such a little bit slower, but still much more competitive in the market.
Thank you. Thank you. And here is another question from Flora Rexepi from Hart. What is the main difference between the European Union approach and the approaches such as South Korea or China's? Is it a policy support for Hyperloop or research funding or something else?
From what I understood, if I may, I think we are facing often the competition from the countries that Flora mentioned, coming in a logic of politically driven approach to bring to the market such type of solution. This is really the matter here. I think Hyperloop, and this is what I was trying to say, Hyperloop need to maintain a championship from the political point of view to bring it to the market. This is the way things can happen. We have seen in the past the high-speed train in France was a willingness at political level to have France as the first having train grand vitesse. The political willingness to go on the space from Kennedy, and so on and so on. So you can put it together. I think here at the moment, what we can see is that we see two countries in particular that can maybe use also in funding in a different way for absolutely different type of reason. I will not enter in this type of discussion, but into which there is a political willingness at a certain point in time to be the first to have the market. Here, this is the reason why I'm saying in Europe, we have been working a lot on Hyperloop with the Hyperloop promoters. We have all the elements to set up the future mode of transport, but we are lacking at the moment really the transition to have it happening. And I think this should be our key priority in the next couple of years. How we transition from the idea, from the work we have done, from the definition of the regulatory framework, the safety analysis, as Sorben said, the economic analysis, and so on and so on, to we want to have a demonstrator, be the first in the world to have a demonstrator showing it works, not in a small scale, it works on large scale, clearly making an effort, and clearly it requires a strong political will. Or maybe we can decide, well, this is not for Europe, and in this case, we need to take another path, if anyone think about it. But I think we have invested so much in different type of resources, and now is the moment in which we need to have the necessary political leadership, as it happened in this country, was mentioned by Flora, to bring it to the market. And we see, if I may, also in the United States, when I was there in January, I think also Constantinos was there, some priorities are changing also there. It's true that the Hyperloop is part of the infrastructure bill, so the famous $3 trillion that will be going around, but also there are some type of evolution. So I think we need to really have a strong and concrete case that we need to bring forward at the political level, and having the willingness at political level to accelerate.
Thank you, Carlo. Okay, and here is a last question for all of you. Do you think there's any missing actor in the Hyperloop constellation that it could be need to range for or to active the research and innovation program or funding to get a real scale in Europe?
If I can start, maybe.
Yes.
I would not see, let's say, missing actors in the ongoing discussion, because we have tried to involve as much as possible relevant actors. What we see, and this also reflects the point made by Carlo earlier on, is let's say a different degree of interest, also of political interest. To give you a very simple example, of course, before the COVID pandemic, there was quite some interest from member states to also think about the future and plan future investments. And then Hyperloop was a perfect topic, a perfect transport mode for them to plan the future. Then the crisis came, and they have focused on, let's say, shorter term priority, and we see some interest going down from member states. So probably instead of having more actors around the table, which we will definitely need at some point in terms of building infrastructure, having operators and so on, we should try to have let's say, level the ambition, level it up, of course, among actors currently involved in the discussion. Thank you.
Thank you. Thank you. So, is there any other question by the audience, please? Now is the moment. No? Thanks. In this case, no more questions. Thank you very much for all of you for this, I think, very interesting session. And Maria Luisa, I give you the power again.
Thank you. Thank you.
Thank you.
Thank you.
Thank you.
Thank you. Thank you very much, Juan. Now it's time to finish our final conference of HYPERNEX projects. I want to thank to our speakers of today, Carlo Borghini, Leonardo Da Giovanni, Constantino Kaumas, Jaime Tamarit, and of course Juan de Dios Sanz, and also our colleagues from the HYPERNEX projects to be here and to share this time with us. And I want to make also a wrap-up of the presentations and the roundtable that we have listened today. From Jaime Tamarit, I think that Jaime emphasized the need to have an interoperability framework. Hyperloop promoters and other stakeholders are invited to establish a common agreements about the Hyperloop technologies and infrastructure to speed up the Hyperloop development. Also, we can find some lessons from the round table. Hyperloop has a great potential as a low energy and carbon neutral transport mode. And Hyperloop seems to be a possible solution to the climate problem. We need to guarantee that it's possible and it really works. The need of the standardization and regulation are a reality. We need to ensure the safety and security of Hyperloop technology, but as a previous question, as Carlo Borghini states, it's a compulsory condition. And also it's necessary, this standardization or regulation for the startups, investors, and other actors. But maybe if we are so slow in this standardization or regulation, it would slow the deployment of the different technologies around Hyperloop. Also, we can take the advantage of the flagship Area 7 and the other budgets for innovation to accelerate the construction of a real size or a large scale demonstrator to demonstrate the benefit of Hyperloop solutions. Now, at this point, I also want to thank to our project officer, Monique van Vortel and Goraz Marinik, for their advice and support, and also their patience. And of course, we want to say thank you to Shift Rail for their funding. We also want to thank to all the HYPERNEX advisors that with their reviews, we could improve all the deliverables. Thank you to all the attendees for the time and presence. And finally, to all HYPERNEX partners for create a great and ambitious and a wonderful work team during this time. I think that it's the time for close the session. Thank you very much. And I hope that we have the opportunity to work together in other projects. Thank you very much.
Bye-bye.
Thank you very much. Also,
thank you all. Thank you very much.
Thank you.
Thank you very much.
Bye-bye.
Thank you
Thank
for
you.
the excellent organization, Maria Luisa.
Yes, thank you. Welcome.
Thank you. Bye-bye.
Thank you.